Okay, today I will be doing the AP Calculus BC exam, the 2012 practice exam. This part is the Section 1 Part A, which is just the non-calculator multiple choice portion. Before we get started, there's a few tips I want to say. Number one, you only have 55 minutes and there are 28 questions, so on average, you want to take, 2 minutes per question. Obviously, some will take less, some will take more. Hopefully, most of them will take less, so you have more time for the harder ones. And the most time I would recommend spending on any problem is 4 to 5 minutes because it's a multiple choice test. So if you spend more than that, just skip it, finish the rest of the test, and then go back to it. It's just some pretty basic test taking strategies. So now let's get started. I have 55 minutes. I have a timer here. And yeah, I have to start now. All right, for number one, uh, I mean, here you just differentiate it. It's um, just basic differentiation. Be careful because you still have to take the chain rule into account. For number two, all right, so the particles at rest when both x prime t equals 0 and y prime t equals 0, right? So when x prime t equals 0, that means 3t squared minus 6t, because that's just dx over dt, equals 0. And when y prime t equals 0, 12 minus 6t equals 0. So that means t equals 2 for y prime to be equal 0. And you plug that into x, you see 3 times 2 squared minus 6 times 2. This is 12, this is 12, so it is 0. So when t equals 2, the particle is at rest. And when t equals 2, xt equals 2 cubed minus 3 times 2 squared. So this is 8, this is 12, so it's negative 4. And y prime t, yt equals 12 times 2 minus 3 times 2 squared, right? This is 24, this is 12, so it's 12. So the answer is negative 4, 12. All right, so you want to find this value right here. Uh, you just take the, you just take the area, right? So this is 2, since this is 1, this is 4. So this area is 4 here, this area is 2 here. And since this is negative 3 and this is 2, this area is negative 6 here, right? So you just add these up and it's just 0. All right, so you want to find the length of this curve. Uh, and this is just, you know, this is uh, just formula memorizing because it's in terms of x. So you're integrating with respect to x because it's from x equals 1 to x equals 2. So it's just, I mean, you just remember the formula. Um, all right, so when you want the value of f of 3, so you just plug 3 into x here. So starting at n equals 0, so the first term is 1, and then you have, and this is just a geometric sequence um, with starting term 1 and common ratio negative 3 over 4. So you can just use the, I don't know, the closed form formula to find. So it's just n to the power of infinity, because this here is infinity. This is like not, it's not like legit, um, but it helps me visualize it because this just equals 0 because this is less than 1. So it's 1 over, well, 1 plus 3 over 4, 7 over 4. So it's just 4/7. All right, so you just substitute this in here. So du over dx equals 2x. So dx equals du over 2x. All right, so you plug that into here, and you have this right here equals 1/2 of, well, when x equals -1, u equals to -2. And when x equals 4, u equals 13. And then these x cancels out, so it becomes u to the power 5 du. Uh, so it would be C. Alright, so you have the inverse sine of x equals the natural log of y. So you can just take the derivative. Um, the derivative of the inverse sine of x, I believe, is 1 over the square root 1 minus x squared. But if you don't know, you can just draw it out. You have, since sine -1x equals y, that means x equals the sine of y. So if you draw a triangle here, this equals to y, and the hypotenuse to be equal to 1, this is x, because sine of y is just x over 1. So that means, um, sorry, uh, my bad. Uh, this comes later. Well, once you have this equation, you can differentiate it. So you have 1 equals y prime cosine y, right? Now here you use this part. Cosine y is just this side over this side. Well, by the Pythagorean theorem, this side is just 1 minus x squared. So yes, y prime equals 1 minus square root 1 minus x squared, because you plug that into here and divide by both sides. So you have this right here. Now, since you know the natural log of y equals the inverse sine of x, that means raising both sides to the power of e, you have y equals e to the power of the inverse sine of x, right? And you can move that here, so you have y prime equals e to the power of sine the inverse sine of x over square root of 1 minus x squared. I mean, you didn't even need to do that part. They had this in terms of y, but in case you needed to. All right. So a tank contains 50 liters of oil at the start. At the start here. All right, and now you want to use the Riemann, I guess. I don't know how to pronounce it. Right, Riemann sums. So in order to since these are the liters per hour, to find the liters, you just take the area under the curve, right? So if I just draw it to visualize it here, if we set this part to be 50 liters, if we set uh, where y equals 0 would normally be to 50 liters, um, then to visualize it, we just have, so this, okay, sorry. Um, I'm not really sure how to explain it, but if we just have a graph of the liters per hour, or RT here, and this is T, so this is 6.5, right? And this is 4. So let's say this is 7, this is 12, and this is 15. All right, and we have 6.2 here, 5.9 here, and 5.6 here, right? Since we're using the right Riemann sum, we don't care about this first part here. We only care about these values. So to just do it, this distance is 3, and we're using the right side, so this is 6.2. So we have 6.2 times 3, which is 18.6. Next we have 5.9 times 5, because this distance is 5. So 5.9 times 5 is 29.5. And here we have 5.6 and 3 again. So we have 5.6 times 3, it's 16.8. So we add these together, 18.6, 29.5, 16.8. Let me do some addition here. We have 64.9. And then we add this to our starting 50. So we have 114.9. So that's our answer. Alright, so we want to know which of these series converges. So assuming you didn't memorize a bunch of ways, we can just test each of these. So for the first one, we can use the ratio test. So we have, if we set an equals this part here, right here, we have an plus 1 over an equals 8 to the power of 8 times 8 to the power of n divided by n plus 1 times n factorial over 8 to the power of n over n factorial. So this is equal to, well, these parts just cancel out, and this cancels out. This is equal to 8 over n plus 1. So the limit as n reaches infinity of this is 0. So that means 1 converges. So we just circle 1 here. For 2, we can also use the ratio test. We have 8 to the power of n plus 1 over 8 to the power of n is equal to n plus 1 times n factorial over n plus 1 to the power of 100 divided by n factorial over n to the power of 100. So these n factorials cancel out, and we're left with n plus 1 times n to the power of 100 over n plus 1 to the power of 100. All right, hang on. Let me think for a while here. Well, I mean, the limit as this reaches infinity is obviously just going to near 0 because this part is greater than this part. So 2 also converges. All right. Okay, so for number 3, I believe we can still use the ratio test. So we have an plus 1 over an. And this is equal to, right, an plus 1, this is just n plus 2 over, sorry, n plus 2 over n plus 1, n plus 3, and n plus 4 over n plus 1, n plus 2, n plus 3. Right. So these cancel out, and we're left with n plus 2 squared times n over n plus 1 squared times n plus 4. All right, so now sorry, my bad. All right. Uh, Now I can cheese it and say since 1 and 2 both work, the only solution that contains both of them is E. Alright. Um, Now we just have this integral here. We can just do it. So we have t to the power of negative 1/2 times negative 2. Right, so the derivative of this is just t to the power of negative 3 over 2, 1, 4. So this is just, if we plug in 4 here, if we plug in 4 here, we have negative 1 minus, because this is just negative 2 over square root of t, right? So if we plug in 4 here, this is just 2. So yeah, if we plug in 1 here, this is just negative 2. So minus negative 2, so it's just 1. All right, so this function here, we can just, I guess we can just draw it. So this is shifted to the right. This, this is just f of x equal, okay, if we consider when x minus 2 is positive, so it's symmetric around x equals 2 right here. All right, when when it's greater than this, it's just equal to the square root of x minus 2. So it looks something like this. When it's less than it, so when x is less than 2, it becomes square root of 2 minus x. So it looks something like this. All right, so a is true because it is continuous, but it's not differentiable. It's continuous because the limit as it reaches this point is equal to just the value itself. So now we can just circle it and we could be done if we're short on time. If we're not, we can just check the other ones. Well, no, it's not differential at 2 because it's, it like breaks apart there, if you know what I mean. This is not true because it is continuous. The limit is equal to 0. The limit is equal to 0 because the limit from the left is 0 and the limit from the right is 0. And this is not a vertical asymptote because, you know, it doesn't like go, it hits the value. It's defined at x equals 2. All right, so we have the differential equation dy over dx equals x squared plus y. And we have the points -1, -1, and 1, -5 are on them. All right, so we can just plug these values in. So when x equals -1 and y equals -1, dy over dx equals 0. And when x equals 1 and y equals -5, dy over dx, when y equals 1 and when x equals 1 and y equals -5, dy over dx is -4. So, um, and then if we differentiate this again, so we have d squared y over dx squared. This is equal to 2x plus y prime. So if we plug this in to here, we plug this into here, d y prime prime at -1, -1 is just equal to, since y prime is equal to 0, y prime prime equals -2. So this is one group, and y prime prime when x equals 1 is equal to 2, because you plug in 1 here. So it's 2 minus 4, because that's what y prime is here. So it's -2. Okay, so we can just check now. negative 1, negative 5 is not local maximum because the first derivative is not 0. And it's not a point of inflection because the y prime prime is not 0. So now we look at negative 1. Is it a local maximum? Well, yes, it is because it's concave down since the second derivative is negative. So it looks something like this. So this is true. We're going to look at the other ones. It's not a local minimum. It's not a point of inflection because the y prime prime is not equal to 0. So it's C. All right, we want the radius of convergence of uh, this abomination. So we can try to use the ratio test. So we have an plus 1 over an is equal to over an equals this thing right here. Right. So we have n minus 3 to the power of 2 n plus 1 over 3 to the power of n minus over 3 to the power of n plus 1 all over n minus 4 to the power of 2n over 3 to the power of n. So this is just equal to 3 times n minus 4 to the power of 2n under n minus 3 to the power of 2n plus 2. Alright, so we know this has to be less than 1. Well, this might be a problem that I am going to have to skip. Uh, I'll spend a few more minutes on this, but if I can't, like I said before, I am going to move on. We could try something like this is always going to be positive, so this doesn't really matter since these are all even. Alright, I'm going to skip it now because I do not know how to do it. Alright, so this is more of a how do I say it? It's more of a problem that requires you to know like definitions. So you have to know what a logistic differential equation is. You don't really need to actually like do anything here, but I'm pretty sure a logistic differential equation is something of the form dy over dt in this case equals some constant k times y times 1 minus y times k. Sorry, not sorry, ky times 1 minus k. I believe. Um, there's really no way to check to see if you did it right. Like here, um, it's not a solution. It's either K or P. So it's not P. Sorry, it's a Y in this case. So I'm just gonna do it. Yeah, that's what I'm saying. Like you don't really know if you're doing it correct or not. All right. So we have h of x, then we have all of these values here. So we can just calculate them ourselves. So h prime of x is just f of x, right? So this graph is f, and h prime prime x is just f prime x. So we really only have to compare the integral of the integral of f of x until um, sorry, until x equals 6, the value at x equals 6, or the derivative at x equals 6. So the integral at x equals 6, the integral here, the integral from 0 to 6 of f of x dx is less than 0. We don't need to find the actual value, but we just need to find it relative to each other. F of x is 0 at this point, and f prime x is greater than 1. So from least, this is from least to greatest. So from least to greatest, it's h6, and then it's h prime 6, and it's h prime prime 6. So it's just the first one right here. All right, so you just need to use Euler's method. So the initial condition is f1 equals 3, and dy over dx equals x minus y. Now, it's going to be a bit messy because I'm not the best at organization, but I'll try my best. So on the first step, okay, let me draw a table here. On the first step, we keep track of the x value, the y value, and the y value. So the x value here is 1, the y value is 3. So dy over dx is just negative 2. Let's write that here. So then the new x, say new x dy. Since the step is x equals 1, that means the new x is just 2. And since the derivative is negative 2, the new y would be 3 minus 2, which is 1. On the second step, we take this here, so 2, 1. dy over dx is just 2 minus 1, which is 1. So new x is 3, and new y is 2. So it's just 3, sorry, 3 comma 2. Sorry, my bad. I misread the problem. It's 2 steps until you reach f of 2. Sorry. So in fact, the new x would be 3 over 2, and the new y would be 2, because you go up 1/2 and you're going down half of this. So now new x is 3 over 2, new y is 2. So dy over dx is just this minus this, which is negative 1/2. So the new x is just 2, and the new y is this divided by 2. It's this divided by 2 added to this. Sorry. This divided by 2 added to this. So it's just, I believe, 7 over, sorry, my salus isn't working that well. 7 over 4, um, so we want to see uh, what this converges to. to make things easier, I can just list out all the known power series. So sine x is equal to in general, if you have a function, the power series representation of it is f of 0 uh, plus f prime 0 x over 1 plus f prime prime 0 x squared over 2 factorial plus prime 0 x cubed over 3 factorial dot dot dot. Right, so sine of x, well, sine of 0 is just 0. The derivative of sine of x is cosine x, and cosine 0 is 1, so it's plus 1. And this is 0 because it becomes negative sine x. And then it becomes negative cosine x, so it's negative 1, so it's negative x cubed over 3 factorial. And this just goes on, so it becomes plus x power 5 over 5 factorial, dot dot dot, right? For cosine x, it's 1 minus x squared over 2 factorial plus x to the power 4 over 4 factorial, dot dot dot, right? Because it's like shifted. Sorry, I don't know what happened. And e to the power of x, well, I mean, we already have our answer. We just check, sorry, we can just check against each of these. So we have cosine, that's not right. We have sine, that's not right. Well, we have sine x over x. It's just, this becomes 1 minus x squared over 3 factorial plus x to the power of 4 over 5 factorial, which matches here. So we have C. All right, so we know the graph of the derivative, and we want to find the value of the actual function itself. So we can disregard this for now. We just want to know like the change in the graph between here and here, right? So what is this? Well, this is 3, this length is 3, this is 2, so this is 3. And now we need to find this area here. Well, this is just a radius of 2, a semicircle with a radius 2. So the area is just 2 pi. And now we take a look at this. So, sorry, it's negative 2 pi. So, since you're going backwards, you have to subtract this. So you have 1 minus negative 2 pi plus 3. So this becomes 2 pi minus 2. So, alright, so you just want f prime x equals 1/2, right? So we can just use the, and we just differentiate it. It's pretty straightforward. Alright, so we have 4 equals x plus 2 squared. So x plus 2 equals plus or minus 4. Sorry, not plus or minus 4. Plus or minus 2. So x equals 0 or 4. Now I plug this in. When x equals 0, f of x equals 0. And when x equals 4, f of x equals 2 over 3. So we didn't actually have to do it because the only x values here are 0 and 4. But, sorry, my bad. It should be c because it's not 0 or 4, it's 0, negative 4. My bad. Don't, it's better not to make any mistakes during the test. It's better to look at the problems when you've done twice, which is why after the test you should look at your answers twice. Alright, so now this is just asking you to integrate, which we can do. Just have integral. Sorry, we just have the integral from 0 to 1 of 5x plus 8 over x plus 2 times x plus 1 dx. And now we can just do partial fraction decomposition. There is a shortcut to do it, but I'll just do it the quote-unquote normal way. So if we just look at this right here, right? This is equal to a over x plus 2, sorry, ax plus b over x plus 2 plus cx plus d over x plus 1, right? And this is equal to 5x plus 8 because we're looking at the numerator right here. So if we multiply, sorry, this is equal to 5x plus 8 over x plus 2 times x plus 1. Now if we multiply these out right here, right? If we multiply it by x plus 2 times x plus 1, we have ax plus b times x plus 1 plus cx plus d times x plus 2 equals 5x plus 8. Sorry, not. I'm not the best. Sorry, there's no ax. It's only b and d. Or it should be a and b, but so we have bx plus dx equals to 5x. So that means b plus d equals to 5. And now we have b plus 2d equals 8. So now I can just see d equals to 3, b equals to 2. So this is equal to the integral from 0 to 1 of 2 over x plus 2 plus 3 over x plus 1 dx. So just erase. Right, so this is just 2, since it's from 0 to 1, the natural log, it doesn't really matter that it's absolute value. So it's the 2 times the natural log of x plus 2 plus 3 times the natural log of x plus 1, right, 0, 1. So this is equal to 2 times the natural log of 3 plus 3 times the natural log of 2 minus 2 times the natural log, sorry, minus 2 times the natural log of 3. So these cancel out, and you bring this power up here. So it's just the natural log of 8. All right, so now this is telling us the derivative of, so y prime 5 is equal to 0. Right, so right away we can see this is not, because y prime is always equal to 5. But now we can just, we have to just bash the rest. So y prime, for c, y prime is equal to the natural log of x minus 5. So this, Sorry. So this, right, this is undefined. So, sorry, I don't know what keeps happening here. All right. Sorry, I am pretty my bad. I took the integral instead of the derivative. Sorry. So y prime is equal to, right? This is still undefined, so C is out of the question. Now look at A. All right. So now I don't know if this is 0 or not, but in order for this, yeah, I mean, I don't know if it's 0 or not. So we can just move on to the next one and eliminate the rest. So y prime here is equal to x minus 1 squared, 5 times 1 minus x plus 5x. Right. So if we plug in 5 into here, well, this is negative 4, this is negative 20, this is 5. So no, this doesn't work either. Now it's either E or A here. So we have y prime is equal to, now we have to see if this equals 0. So we plug 5 into here, we have 101 times 101 times 199 minus 20 times 25 minus 5 times 40. And this is not. So uh, by by sorry by elimination, sorry, it's going to be A. But uh, yeah, sorry, by elimination it's going to be A. All right. It turns out I actually did this problem wrong. I completely misunderstood it. I don't know what is happening. Um, but this shows um sorry, my bad. For for it to be a horizontal asymptote, it means that y prime has to be equal to 5 for sorry, y prime equals 5 when y equals 0, right? Sorry, y prime equals 0 when y equals 5. So we can take a look at the first one. So when y equals 5 here, we have 5 x equals sine 5x. 5, sorry, 5x equals sine 5x. Uh, so if we just draw the thing, it looks something like this, right? So there might be 2 points of intersection, but we can first consider the first one, when x equals 0. When x equals 0, the derivative of this is just, right? And then when you plug in 0 here, it's 0. So yeah, this works. All right, so this converges at x equals to 5. That means it's like, because if this is, if it's increasing, um like if the limit of as n equals to infinity of this value here, if this is ever greater than 1, that means it's it's divergent, right? So I'm not really sure how to say it, but like if okay, when x equals to 3, it's obviously convergent, right? And it's convergent at x equals to 5. That means it has to be convergent at x equals to 1. Because if you're going 2 up to 5 and it's still able to converge, um, if it's still able to converge x with 5, you can, it's like, it's mirrored, right? Because it's like x minus 3. So it still converges at x equals to 2. Oh, sorry, x equals to 1. I mean, it's just linear growth, so, you know, it's pretty simple. All right, sorry. So, um, you can just view this kind of like, I guess, I mean, it kind of reminds me of differentiation um, by parts. So I might try that. Um, so we have, well, if we multiply both sides by -1, we have the integral of f of x times negative sine x is equal to f of x cosine x plus the minus the integral of 4. Right, so now this looks a lot like differentiation by parts. Because if we have dv equals negative sine x, then v equals the cosine of x, right? And if we let if we let u equals f of x, then du equals, well, equals 4x cubed. So that means du equals 4x cubed. So that means u, um, sorry, du equals 4x cubed. Wow, this is like, because, sorry, dx. Sorry, right. So if du equals 4x cubed dx, then u equals x cubed, x to the power of 4. So, all right. So I want to know what this value is. You can just u sub u equals x squared. So du over dx equals 2x. So dx equals du over 2x. Right. So, well, we plug that in. We have 1 integral from 1 to infinity of 1/2 of e to the power of negative u du. Well, this is equal to negative 1/2. Sorry, we still have to, never mind. Sorry. So we have negative 1/2 of e and 1 in infinity. So e to the power of negative u. So this is the limit as n reaches infinity of, sorry, this negative 1/2 times the limit as n reaches infinity of e to the power of negative u minus e to the power of negative 1. Well, this is just 1 over e to the power of u, so this is 0, because this becomes infinitely large. So this just becomes a positive 1 over 2e. All right, when theta equals 0, r equals to 1, uh, we can just convert into rectangular. So r equals the square root of x squared plus y squared. This is equal to 1 plus 2 sine of tangent inverse of y over x. If we have if we have y here, x here, and this is a tangent inverse of y over x, then the sine of this is just y over the square root of x squared plus y squared. So this is square root of x squared plus y squared is equal to 1 plus 2 times the sine of this is y over this, so y over square root of x squared plus y squared. Now r equals to 1, so we can just plug that in. So 1 equals 1 plus 2y. So y equals to 0. Oh, sorry, my bad. I was saying something else, my bad. Um, sorry, if we multiply both sides by the square root, now we can just take the derivative, so times all right, so we can just plug now. I do not know what keeps on happening. We know y equals to 0, so that means since r equals 1, that means x equals to 1. So we plug that in, x equals to 1 here, y equals to 0, x equals to 1, x equals to 1, y equals to 0. So this is just 1, so that means 2y prime equals 2y prime is equal to 1, so y prime equals to 1 half. And that's time. All right, so I didn't get to finish all the problems here. I did get stuck and I did make a few mistakes, but um, in general, but as I showed you guys, I skipped over the ones that I could not do, where I identified that I would take a long time to do, or I had to rack my brains to search for an answer. And I was able to get most of the problems done. I think I got, I skipped 2 or 3 problems, but yeah, if you can't do any problems, just skip over them. If you can, it's obviously better too, but um, not everyone's perfect. All right, so that's section 1, part A done.